Alright, so 3.5, B as in boy, and we are continuing on with asymptotes. We've kind of gone over the vertical asymptote, told you how to find them, not too bad. Now we're going to do a horizontal asymptote, which, let's say we have a graph that looks like this. Okay, it does not cross the y-axis. So because of that, or the x-axis, so the x-axis becomes the horizontal asymptote. Okay, so how do we find that thing? How do we find a horizontal asymptote? Well, when our expression is written so that our leading term has the same exponent, so that over our horizontal asymptote will be having to do with that. So 3x squared over 2x squared, those cancel, so my horizontal asymptote is 3/2. Not too difficult, is it? Okay, but it only works when the degrees are the same. Now when the degrees are different, we'll get into that in a minute, but let's look at example 4 and just see what's going on here. We have f of x equals negative 7x to the 4th minus 10x squared plus 1 over 11x to the 4th plus x minus 2. Alright, so when it says find the horizontal asymptote, it makes it real simple there. Horizontal asymptote is negative 7 over 11, which means we go to negative 7 over 11, which is going to be right in there, and we draw a dotted line horizontally. And if we have a graph above and below, it will come up to it, but it won't cross it. Okay? So let's look and see what happens to a horizontal asymptote when the degree of the numerator is less than the degree of the denominator. So maybe it'd be negative 7x cubed instead of x to the 4th. So this term is going to have a numerator with a degree less than the denominator. So maybe this will be a 3 and this will be a 4. This will be a 1 and that'll be a 4. Okay? Okay, so this is example 5. Notice my exponent on my numerator and my leading term here is smaller than my x cubed. So we're going to find the horizontal asymptote of this. So one of the things I want to make you aware of, let's go ahead and draw a graph here. What happens as x approaches infinity? As x approaches infinity, my y value gets smaller. As my x approaches negative infinity, my y value gets smaller and smaller. And that will pretty much be the case for any number that I put in here. If I put a 1 in here, I get 5. If I put a 1 in here, 1 minus 2 is negative 1, plus 4 is 3. So I get 5 over 3. As these values, as the numbers I plug in for x get bigger and bigger and bigger, the bottom, the denominator, will grow faster than the value up here. Okay, so because of this, this fraction here, as x gets bigger, this fraction will get smaller and smaller and smaller. So as x approaches infinity, my y approaches 0. So what happens is whenever my denominator, leading term, is larger than the leading term of my numerator, my horizontal asymptote will always, always, always be 0. Okay, so horizontal asymptote when the numerator leading term is smaller than the denominator leading term, my horizontal asymptote will be 0. It'll be the x-axis. And you may ask, what in the world happens when I have my numerator bigger than my denominator? When this one's bigger, it means there is no horizontal asymptote. Okay? So those are your three things. If you look at the top of 308, it gives you 3 different occurrences for horizontal asymptotes, how to find them. So they're really, really easy to find. So hopefully that part of it will go really smooth for you. But there is a little bit of a difference between a horizontal asymptote and a vertical asymptote. A vertical asymptote, one that goes up and down. A rational function will never, ever in the whole history of the universe cross that asymptote. A horizontal asymptote, on the other hand, usually does not cross the horizontal asymptote, but it can. Okay, you might run into some that once in a while will cross, but usually they do not. All right, let's look at example 6 here. We have g of x equals 2x squared plus 1 over x squared. So what they're wanting us to do is graph this and include and label all of the asymptotes. All right, so the only asymptote that we're going to get that's vertical is what makes the denominator 0. Well, the only number that makes that denominator 0 is 0. So our x-axis is our vertical asymptote. Okay, and there's only one. All right, and let's see, what is our horizontal asymptote? And that's going to be 2 over 1 because these are the same. So it's going to be this number over this one. So our horizontal asymptote is going to be 2. Okay, not too bad to find that. Now to draw the graph, we put on the asymptotes like we did, and then we put on some points in order to see what happens to the curve. And when we put in a whole bunch of points there, we find out that the graph is going to look like that when all is said and done. Okay, sometimes a line that is neither horizontal nor vertical is an asymptote. Okay, so sometimes we may, and let me get a different color here, we may get an asymptote that looks like this. That maybe, and I'll do this with black, make a graph. You might get a graph that looks like this. Okay, where it doesn't have a horizontal asymptote, it has this one that's not horizontal or vertical. It's called an oblique asymptote. Or another word that they use sometimes, I haven't seen it very often, is a slant asymptote. So you got to be careful that there might be one of those as well, and we'll do an example of one here so you can see how that's determined, and we'll go from there. So let's look at example 7. We have f of x, and that equals 2x squared minus 3x minus 1 over x minus 2. All right, what they want us to do is just find the asymptotes. So we're going to look for a vertical asymptote, horizontal asymptotes, and see what we have from there. All right, so we can tell right here we have a vertical asymptote of 2, because that's what makes that 0. Because our numerator leading term has a higher degree than the denominator, this is 2 over 1, then it does not have a horizontal asymptote. So all we have is the vertical asymptote at positive 2. Okay. So the next question is, how do we determine if there is an oblique asymptote? Okay, because we just looked at this and found that we have a vertical. We also found that there is no horizontal. Okay, the only time an oblique asymptote occurs is when there is no horizontal. If there would have been a horizontal asymptote here, then we wouldn't even have to consider an oblique asymptote. But since there was not a horizontal asymptote, there could be an oblique asymptote. Okay, how do we find that out? Well, when the degree of our numerator is 1 greater than the degree of our denominator, then we've got an oblique asymptote. Okay, which is the case here. If there was a difference between these two of more than 1, we wouldn't have to worry about it. But since there's only one difference between x squared and x to the first power is 1, then there's going to be an oblique asymptote. Okay, so how do we find the oblique asymptote? What we're going to do is we're going to do division. We're going to divide that. And we're going to use synthetic division. So we're going to look at this. And you can use long division if you want, but I would prefer using synthetic. 2, 4, 1, 2, 1. So we get 2x minus 1 plus 1 over x minus 2. Alright, this part right here, where I made a mistake, that should be a plus sign, shouldn't it? That is the value, that is the slant, or the oblique. So y equals 2x plus 1. So we just graph this. 2x plus 1. Y-intercept is 1. Our slope is 2 over 1, so up 2 over 1, up 2 over 1, up 2 over 1. Okay, so there is our oblique asymptote. And then when we actually graph that, our graph is going to have, it's going to be there, and it's going to be there. Okay? So that's how you find the oblique. You determine whether there is one, if there is not a horizontal asymptote, and if the difference between the two leading terms is 1, exactly 1, then you divide, and the answer without the remainder is the equation for the oblique asymptote line there. And that's how you draw that. Okay, I'm going to stop this one and continue on with 3.5c.